Our math adventure continues. We're going to build on what we learned about ratios, and we're going to start to talk about proportions. Now remember, a ratio is simply a comparison of two things. A rate is a ratio that compares two things that have different units of measure. When we start to take a look at proportions, all that a proportion is it's an equation where we're comparing a ratio to another ratio that are equivalent. Now, the way we can look at this is we can say 2 is to 3 as 8 is to 12. But how do we know if they're really equivalent? Well, one thing I can do is I can reduce both parts of the proportion to lowest terms. And if they are the same in lowest terms, then I know they have to be a proportion. Now, 2 to 3 is already in lowest terms, but 8 to 12 is not. So what I'm going to do is I'm going to go and I'm going to reduce that to its simplest form. And I'm going to divide both the top and the bottom of the ratio by 4. And when I do that, I get 2 to 3. In lowest terms, both sides of that proportion are the same ratio. That means they have to be proportional. Now, we can also solve for variables when we're working with proportions. Today, we're just going to look at equivalent ratios. Sometimes the math is really easy for us to do just by using multiplication or division. So if I have this proportion, 5 is to 6 as x is to 18, my job is to figure out what x is. So first I just take a look at the numbers and I look for the two numbers where the numbers are given. So in the top, I don't have both numbers given. One of my unknowns is in the top. But when I look at the bottom of that proportion, I have both those numbers. What I think to myself is there anything I can multiply 6 by that's going to get me 18? Well, I know that 6 times 3 is 18. And remember, in math, you always have to keep it balanced. So whatever I do on the bottom, I do on the top. I know 5 times 3 is 15. Therefore, x has to be 15. When we take a look at that proportion, 5 is to 6 as 15 is to 18. Remember, if I put them both in lowest terms, they should be the same number. And if they are, then I know they have to be proportional. So 5 is to 6 is already in lowest terms. So I'm going to divide both of these by 3. And I get 5 is to 6. Because they are the same number, they have to be proportional. And I'm sure that x has to be 15. Now sometimes you have to reverse the direction. So again, I'm taking a look at what numbers are given to me. But because x is in the first position, I actually go backwards on this. And I think to myself, I'm starting with 56. How do I go down to 8? Well, I know that I can divide by 7. And whatever I do on the top, I do on the bottom. So I'm thinking to myself, 56 divided by 7 is 8. Therefore, 35 divided by 7 has to be, and I'm thinking 5. So now I'm going to go check. If I think that x has to be 5, I'm going to build that proportion. So I'm going to say 5 is to 8 as 35 is to 56. Well, again, let's look at them in lowest terms because that always tells us if they are proportional. So I know that I can divide both of these by 7. And when I divide 35 by 7, I get 5. 56 divided by 7 is 8. They are the same. Therefore, that is a proportion. Our job is to build proportions. We have to make both sides work. And we're going to use equivalent ratios in order to do that. The challenge is up to you. Are you ready to go?